Good evening. Now we will see the questions. So I will try to prepare video for all possibly. Now we will go with first video. Now in this, what is difference between analysis and design? Already we have seen in the class. We have analysis means to find the forces. Analysis. This is to find the forces due to external load this is first analysis. So if we have given a load beam and then UDL is given or we have calculated and we are interested to design the beam, then we are going to analyze it. What does it mean? If this is 40 kilonewton per meter, we have 2 meters. Then we are going to get reaction that is 40 kilonewton, and then we have bending moment, which is WL square by 8 for simply supported, and we have 40 into 2 square by 8, and that will be 8 fives and 4 fives. So we have 20 kilonewton meter. And then we have to design it for shear force 40 kilonewton, bending moment 20 kilonewton meter. Units, keep in mind, we have stress unit, Newton per mm square. Then we have UDL, kilonewton per meter or Newton per meter, Newton per millimeter. Then we have shear force, Newton, kilonewton. Then we have bending moment, kilonewton meter. We have Pascal, that is for stress, Newton per meter square. So these units we should know. So we have this analysis. First, we are going to find forces due to external loads. Then we have design. What does it mean? So we have to determine cross section of the member. Determine cross section of the member, because length or already decided, our plan is finalized, and after that we are going to analyze and design the structure. So we have to find cross section. Cross section means width and depth. That we are going to find out. It may be beam, it may be column. If we have footing, then also we are being in the same fashion. In footing, we are going to find L also, we are going to find B also, and we are going to find D also. In columns, already we know floor to floor height. In beam also, we know distance between the columns. So in beams and columns, we are going to find out cross section and reinforcement, we can say. That is along with reinforcement. And in case of footing, we are going to find out L, B, and D, all three. And after designing, we are going to again analyze. After designing, we are going to again analyze. After designing, again analyze. And this analysis is to find moment of resistance. To find, or I can say in short, to find the strength of the section. Strength of the provided section, I will say. Provided section. So this is again analysis. Means analysis we have. Analysis we are doing to find bending moment first, and then we are going to analyze to find moment of resistance after design. And after designing, when I will find moment of resistance, which is strength of the section, strength of section, and this value should be always greater than or at least equal to bending moments. Means strength of the section should be greater than load coming on it. If we have axially loaded column, then our strength of the column should be greater than the load coming on it. So likewise, we have to do the analysis and design. Simply analysis to find forces, design to find cross section. After designing, again analysis to find strength of the section. What is difference between working stress method and limit state method? Simple. Working stress method use in working stress method, we are going to use only elastic region of the materials. Elastic region of the strength of material, materials. And if I will say limit state method, so I will write short. Limit state method, we are considering elastic plus plastic. Elastic plus plastic. So how we can explain this? So if I will consider a mild steel, then we have mild steel stress strain curve in this fashion. So when we have working stress method, we are going to consider only linear part. So we are with only yield stress value. But while limit state, we are going to consider that is value up to ultimate stress. So we are considering elastic as well as plastic region, which is also known as strain hardening. This is also known as strain hardening. Already you have seen this in MOS. So elastic plus plastic, and that will be in limit state method. Then draw stress and strain diagram for working stress method and limit state method. So for working stress method and limit state method, strain diagram is always linear. So we have this will be working stress method, we have this will be strain diagram. I will say I will not write in working stress method because we are not interested with this. And then if we will go to the stress diagram, then we have stress diagram in this page. We have here that is sigma S, or I can say sigma C, that is stress in concrete in compression. It may be sigma CC, and this will be sigma ST by M. So as it is triangular, so working stress method is very easy for calculations. Very easy for calculations. And years we are using this in India. So outside this was absolute very earlier, but in our India, that is in recent 5 to 10 years, that method was absolute. Now when I will go for limit state method, so we are mainly interested with this. And in this limit state method, strain diagram we have linear and we have value. So this is 0.0035, and here we have 0.002 plus 0.87 Fy upon Es. So this you can write in this fashion also, 0.002 plus Fy upon 1.15 Es. We know we have factor of safety, partial factor of safety for concrete is 1.5, and for steel it is 1.15. So if anyone asks how this 0.87 comes, so that is Fy upon factor of safety. And now the main important part in this, that is stress diagram. I already explained this in one video, how this stress block diagram comes. So we have seen there, we have FCK value, then it comes 0.67 FCK considering size factor, and then 0.67 FCK divided by gamma m, partial safety factor for concrete, which is 1.5, and then we will get this value as 0.446 FCK. Then we have this value that is at 3/7 XU 0.002. We have this value and this 0.002. So actually we have rectangular block and 0.002, that means we have this as 4/7 of XU. And above this we have 3/7 of XU. And then we have compressive force over here. So we have CU. Now you can show left or right, that doesn't matter. And then we have reinforcement force, that is TU. And these two are acting up in opposite direction. So this is my stress diagram. Now you should be in position to show in IS code, which we have on clause number 38. I think that is in video number 2. You have to go through and you should be in position to explain all the stress block parameter, how this value comes 0.36 FCK into XU. Unit of this we have Newton per millimeter. If you multiply this by B, then we have this as compressive force in Newton. This is compressive force per millimeter. And then likewise we have this stress strain diagram. Then we have derived formula to find neutral axis factor. So now I will draw this diagram of strain diagram, I can say. So we have this value 0.0035. We have value over here point. Already I explained this. If you have gone through videos, go through it, please. We are interested to go 100% result. So then we have this value. This is XU. And we have below D minus XU. And then if you will use similar triangles, then we have XU upon D minus XU, and that is equal to 0.0035 divided by 0.002 plus 0.87 Fy upon ES. And ES, we know we have 2 into 10 raised to 5. If you rearrange it, then you have into 2 into 10 raised to 5 divided by 0.002 into 2 into 10 raised to 5 plus 0.87 Fy. And now if you solve this, then you will get this as 700 divided by 400 plus 0.87 Fy. Now dividendo means we are going to add numerator in denominator, and then we will get XU by D, which will be 700. If we will add, then we will have 1100 plus 0.87 Fy. And this XU by D is nothing but neutral axis factor. So this is known as neutral axis factor, and this is generally denoted by Ku is equal to XU by D, which is equal to 700 upon 1100 plus 0.87 Fy. So my neutral axis factor depends on steel only. Steel only. And if we will see, we have calculated these values. We have Ku max, critical we are going to say is 0.53 for Fe250. Then we have 0.48 for Fe415 and for Fe500. value is 0.46. Now already I have shown clause number and all. You have to go in videos and see it. So it is independent of grade of concrete. Dependent of grade of concrete. This is most important. Grade of concrete. Then we have next question, different types of section considering the reinforcement. So we are going to find out value of Ku. So just we have seen, we have another formula, 0.36 FCK XUB, means we are doing over here Cu is equal to Tu, and that is equal to 0.87 FYAST. Now from this we will get value of XU, which is equal to 0.87 FYAST upon 0.36 FCKB. So if we know D also, then we can write XU by D, which is equal to, already we have seen in Annex G, you can go that video, last video, video 11, there you will see all this, 0.36 FCKB into D. Now this is nothing but Ku. If Ku is less than Ku max, how we will get Ku max? So we have seen that 700. So we have just seen this formula. Ku max equal to 700 upon 1100 plus 0.87 Fy. Knowing grade of steel, we can find Ku max. If Ku is less than Ku max, section is under reinforced. Section is under reinforced. Means steel reaches maximum value first. Maximum stress value first. Now, if we have Ku is equal to Ku max, in this case, steel and concrete both reaches maximum stress value simultaneously. Both reaches maximum stress value simultaneously. This is the most economical section. So when we will design, we have to always design section as balance section. And section, which section is balance section? So we have this section is balanced when my value of Ku is equal to Ku max. And we always design balance section. Now, when Ku greater than Ku max, section is over reinforced and concrete reaches maximum value first. Concrete reaches maximum value first. And due to this, what happened? Our concrete is brittle material, and therefore in over reinforced concrete, failure is sudden, and therefore IS 456 or LSM do not allow over reinforced section because failure is sudden, and therefore we are not allowing. We have to redesign. And if we have to find, we have to redesign DSIG. And if we have to find strength of given section, then we have to use Ku is equal to Ku max to find strength of given section. That means analysis. If section is given and you have to analyze, then you have to take Ku equal to Ku max and then you have to find strength. Then different types of factors. So which types of factors just we have seen first, that is Ku. Then second we have lever arm factor. So how we will get this lever arm factor? So we are in this fashion and my compressive force, this act at a distance 0.42 XU from compression flange, and our tensile force, this is acting at a distance d from compression, farthest compression face. Then the distance, these two are equal and opposite forces, parallel. So we have Cu and Tu equal in magnitude, parallel to each other, equal in magnitude, we have parallel to each other, and therefore forms a couple. And opposite in direction, we have to say opposite in. So third I will say opposite in direction. So these are the three conditions, and they are going to form a couple, and that couple is known as moment of resistance. So what is moment of resistance? Couple formed by Cu and Tu to resist bending moment is moment of resistance. Now the distance between the two forces, this is known as lever arm. And what will be this distance? So we have simply d minus 0.42 XU. Now we have lever arm factor. So how we will find? So we have lever arm that is equal to d minus 0.42 XU. And what is XU? We have d minus 0.42 Ku into d. So because we know, we have just seen Ku is equal to Xu upon d. So Xu is equal to Ku into d. And if we will take d common from the both, then we have 1 minus 0.42 Xu. And this part we are going to say lever arm factor. So we have 1 minus 0.42 Xu. This is second. First, we have neutral axis factor. Second, we have lever arm factor, generally denoted by Ju. And third, we have moment of resistance factor. So we have moment of resistance 0.36 FCK XUB in bracket D minus 0.42 XU. First part we have force, second part we have lever arm. Now, if we will write it, it will be 0.36 FCK. XU we can write KU into D into B into D. And then we have 1 minus 0.42 XU. Now, if I will rearrange the terms, I have 0.36 FCK KU in bracket 1 minus 0.42 KU into BD square. And this part is known as moment of resistance factor. So moment of resistance factor. Moment of resistance factor. And then we have that is equal to point generally denoted by RU equal to 0.36 FCK KU into JU, which is 1 minus 0.42 KU. So likewise, we have to, so what is moment of resistance? Just I mentioned, I have also explained it. That is in last slide only. So moment of resistance is nothing but strength of the section. Strength of section. So likewise, we have to answer the questions. Now we will stop here only. Remaining part we will see in the next video. Thank you.